Biesinger and his history and Mike's role there. I first asked Dave Shoesmith to get this talk, and he says, I know nothing about what Mike did. Then I reached over to Mark. He said, ask Mark. Mark knows everything. I reached over to Mark, and Mark said, I don't know anything. So I said, talk about anything. So it's with great pleasure Mark has agreed to come and talk about the past and present of the CLS, or Surface Science Western. I was somewhere else too long. With that, I'll turn it over to Mark.
So I managed to go find a whole pile of annual reports from way back when. So you'll see a bunch of pictures from that, and I got in touch with some different people and found out some of the history of Surface Science Western that some of them was even news to me. I want to read to you from an article from Western News, and this was in 2001. It was kind of a history of SSW. So the idea for establishing Surface Science Western came on a train journey from Windsor to London in 1980. Chemistry professor Michael Bancroft composed his first written suggestion for the Surface Science facility to then Dean of Science John Bancroft during that train journey. This is a clear illustration of the benefits of travel, wrote John Bancroft in SSW's first report. This suggestion led to academic, organizational, and financial considerations and discussions within the university and the ultimate backing of then President George Connell. Financial support for the project came from Western's Secondary Century Fund, the Academic Development Fund, and the Natural Science and Engineering Research Council. An advisory board was established, and Michael Bancroft was named founding director. Stuart McIntyre was hired as technical director to oversee construction of the laboratory and manage the facility. SSW was given a 3-year timeline to become self-sufficient from contract research and achieve that goal within 2 years. It was an enormous risk the university took at that time to getting into a commercial venture, says McIntyre. It was willing to commit a substantial amount of Second Century Fund money to a relatively narrow area. It was highly unusual that at that time for universities to spend money on industrial liaison and commit their own funds to purchase major pieces of equipment. And Surface Science Western has been an important success story for the university. So back then in the beginning, in 1981, funding raised was about $1.1 million by Western, and that covered capital and operating expenditures for 3 years. $700,000 came from the Second Century Fund and another $375,000 from the Academic Development Fund. It started with 4 staff members, and some of the initial instruments was a dynamic secondary ion mass spectrometer. So we have the Kanika IMS 3F over in the upper corner over there, as well as a scanning electron microscope. And that was an ISI DS30. That was one of the first instruments I used at Surface Science Western years ago. Some other instruments, a laser Raman spectrometer, and again another picture of the dynamic SIMS. That particular dynamic SIMS is still in use today at Surface Science Western and contributes somewhere between $300,000 to $400,000 worth of industrial work every year still. It's been highly updated. We had people over the years, such as Kathy Taylor here, who wrote in-house custom software for that instrument to do things like SIMS imaging, as well as Dietmar Fichter, who invented things that he then sold to other SIMS instruments around the world, things like post-ionization and updated detector systems. Over here we have the Phi 600 scanning Auger microprobe, and then one of my favorite instruments, and probably one of Mike's favorite instruments, was the Surface Science Laboratories SSX 100 X-ray photoelectron spectrometer, and a lot of Mike's students would have used that instrument over the years. Some of the directors through the years started out with Mike from 81 to about 84, then Stuart McIntyre for quite a long time, Leo Lau, Dave Shoesmith, and then myself. There's been a variety of technical, academic, and assistant directors over the years, as well as different operations, technical research, and business development managers and facility managers. Some notable long-terms are people like Ross Davidson, who's the operations manager for about 27 years, and Dietmar Fichter, who was there for 23 years as the technical manager. Present, we have quality managers right now. We've been running an ISO system since about 2007. We're currently ISO 17125 certified. So our quality manager is Rebecca Saracen, and our facility manager is Brad Coley. Some pictures from the early days. We have Mike here, and I think he's working on the computer for the XPS. That looks like the old XPS computer.
He doesn't have a ruler.
I don't know where that is. You can see Stuart McIntyre there, an early picture right there. On the far side is Leo Lau, probably working on Brahman, I think, there. Dietmar Fichter over here, working on some of the electronics, and Ross Davidson working on one of the XPSs, or the XPS. We had a couple of different locations. It started out in the basement of Natural Science Centers, or the basement of Natural Sciences. In '91, we relocated to custom designed quarters in the new Loreno Patterson building, or the Western Science Center, and it's called today. And then in 2007, we moved over to the Convergence Center in Westerns to a research park. And some of the benefits of that has been really easy access for industrial clientele. They can get in and out of the lab very quickly. But we also have very strong ties to a number of businesses within the park, including groups like Arlanxio, which does elastomers and butyl rubber. Polyanalytic is an analytical services provider to the polymer industry. Amtel, which does mineralogical services, which was actually a spin-off from Surface Science Western. Some of the people from Surface Science Western started that company. Hydrograph, Clean Power, which produces graphene. Glabat solid-state batteries of course, and Adias, which does additive manufacturing of medical implants. Some of the logos that Surface Science Western has had over the years, I still have this cup that has the kind of the original logo that they had. And we're now into this purple one that kind of matches up with Western. I want to read to you a little bit about the model that was set up for Surface Science Western. So these are actually excerpts from SSW's first annual report. And it's amazing how similar we still run today from those early times. And we'll have some pictures going through as I'm reading this. Surface Science Western, a new industrial connection for the university. About 18 months ago, a concept for a new type of laboratory began to take shape within Western's Faculty of Science. Surface Science Western, as it has come to be called, is an interdisciplinary laboratory devoted to understanding the nature of material surfaces. What has been particularly unique about Surface Science Western is the major involvement of many other laboratories in its development, including a large number from the industrial and government sectors. Such involvement is very appropriate for a subject like surface science. Many sophisticated developments in the newer technologies require understanding of the very thin exterior layer of a solid in contact with its environment, either gas, liquid, or another solid. The development of catalyst systems for improved control of chemical processes, the adhesive bonding of structural alloys and ceramics, and the fabrication of microwave communication circuits are all areas that would require better understanding of surface or interfacial processes. Fortunately, the science of surface analysis itself has become quite sophisticated over the past 10 years. Many techniques available commercially today were laboratory curiosities in the early 70s. Although the physical principles behind most techniques are straightforward, the instrumentation used for measurements is frequently complex and expensive, both in initial capital cost and in the skilled personnel necessary to operate and maintain it. A variety of techniques is frequently required, each yielding a portion of the information necessary for a complete picture of the surface, its composition, and topography. This type of integrated instrumental facility has not been available in this country previously, and indeed few exist in other countries. Thus, the establishment of such a laboratory at Western Campus has required a major commitment from the university and its supporters. With over $1.1 million was raised by the university to cover capital costs and operating expenditures for the first 3 years. This funding has been used to hire a full-time project manager, to construct the first phase of the laboratory, and to acquire a major portion of the instrumentation. By February of this year, Surface Science Western was open for operation in the Natural Science Center on Western's campus. And that talks about some of the early instruments, SIMS and SEM and XPS. And as important as the instrumentation is, no laboratory could function without well-trained and motivated scientific staff. Each of the 4 staff members added in the past year have brought different skills to the laboratory. The formation of a core group of experienced personnel earlier in the lifetime of the laboratory is expected to facilitate the inclusion of graduate students into the laboratory at a later stage. Surface Science Western is intended to fulfill three main purposes in the university. One, to provide a national resource for the solution of industrial surface problems. Two, to provide an experimental center for more fundamental studies of surfaces already in progress here at Western and at neighboring universities. And three, to teach surface science using both graduate courses and intensive short courses. And we basically have been working in this kind of mode ever since. So, Surface Science Western today. We are, hands down, Canada's leading surface and analysis material characterization facility. We have 16 full-time staff scientists and administration members, including 5 affiliate faculty members, and some of our staff members also hold adjunct professor status and manage their own groups. Wide range of expertise, both in chemistry, geology, engineering. We have physicists, metallurgists, material scientists, somewhere north of 300 people years of experience in surface analysis. The last 10 years, over 250 publications that have been authored or co-authored by staff. We're run by Western as a self-sustaining ancillary business unit, which allows us a fair bit of flexibility in how we operate. User base includes graduate students from Western, as well as university groups from around the world, somewhere between 150 and 200 different companies from across North America annually, issuing somewhere around 1,000 technical reports a year. We've greatly expanded our instrumentation over the years, and over the last 4 or 5 years in particular, we've had some success with CFI grants, as well as some other Ontario funding as well, that we've added quite a bit of new facilities. We have 3 SEMs, scanning OG nanoprobe, 2 dynamic secondary ion mass spectrometers, time of flight secondary ion mass spectrometer, 2 XPSs, Raman, infrared, profilometry, atomic force. A new one to us is the micro CT, laser confocal microscope. We've added an X-ray diffractometer in the last couple of years. We have extensive corrosion electrochemical testing facilities, surface sample preparation facilities, et cetera, a bunch of smaller stuff as well. Our funding model hasn't changed much over the years. We do a lot of industrial support and problem solving. Annual budget somewhere around $2.1 to $2.2 million a year. About 60% of that comes from industrial support and problem solving, so working with industries from around the world. Another, depending on the year, 10 to 20% comes from the typical NSERT Alliance grants or F-type funding, where we're working with industry with matching government funding. Then we also do a pile of academic support, so both within Western would be about 3 to 5% of our budget, and then other universities from across North America would be 3 to 5% of our budget. And then the Faculty of Science also supports us by funding 2 positions, myself and 1 research scientist within the facility. As I mentioned, somewhere between 150 and 200 different companies a year, and these range from small local firms to huge multinational corporations. We're ISO 17025 accredited, and that allows us to, it shows our commitment to a focus on quality of data. We use things like schedule calibration and maintenance and compliance procedures. A lot of industries really need us to have that for them to be able to use our services. So that's an important thing. We're starting to see more and more university labs that are actually doing that sort of thing, where they're getting this ISO accreditation to be able to work with outside the university system. Some of the sectors we work with, we do a lot of work with the automotive sector, of course, Southern Ontario, Detroit, Michigan, there's a lot of stuff in that area. Aerospace defense, we also do a ton of work in the mineral resources sector, as well as energy and nuclear power, but also medical, environmental, electronics, basically everything. Anywhere there's a material or a surface to look at. So I just want to show you some examples of how we work with industry. You see there's kind of some generic samples. Sometimes I can't show you the stuff we're doing with industry because there's confidentiality. So a lot of these are a little bit older, but they still get the point across. So this was, for an example, a multi-layered coatings on glass. And our client wanted to know, what layers were present on the windscreen. So they were doing some reverse engineering of a competitor's project. product. And you can see we do it was an Auger depth profiling where you can go through and you can see the different layers. We have titanium dioxide, zinc oxide, titanium silver, et cetera, et cetera. So these type of work where it's a short-term type analyses, short-term problem-solving analysis, quality assurance issues, things like product returns, warranty issues, reverse engineering. We do a lot of this where it's just very small, short projects that we turn around fairly quickly. Another example would be automotive paint defects, and we have one or two people that almost full-time, this is their job, looking at paint failures, both in the defect side of things and paint that's peeling off, so adhesion failure. And you've seen cars where even paint's peeling off, but we try to figure out why it's doing that. So this was an example where we did some analysis. We saw a particle within the material. Turns out it contains aluminum, zirconium, chlorine, which is a particle of aluminum zirconium chlorohydrates, which comes out of antiperspirant. So the person who was either doing work around the vehicle while it was being painted, some of that came off their person. And so companies spend a lot of money trying to eliminate these sort of problems because the coating systems on your car is one of the most expensive part of your vehicle. And if they have to rework it by getting rid of these defects and repaint, it really adds a lot of expense. So they spend a lot of money trying to eliminate these sorts of problems. And a lot of times we'll have to do this very fast because they're doing, if you're in a parts, they're making thousands of parts a day. And if they're scrapping half of them, it's very, very expensive. And so a lot of our work is done in what we call a rush job or a priority turnaround. We do a 1-day, 3-day, and 5-day turnaround that we offer for extra money, of course. But over the years, the last 3 years, almost 48% of the work that we've done has been expedited to some degree. So there's a rush on it. They need to get this product, they need to get their facility back up and running. They need to eliminate the problems right away. Even 17% was a 1-day turnaround. So it comes in the door, we immediately drop everything, start working on it, feed them results by phone or by text or by email during the day while we're doing it so that they can be solving the problem on their end while we're trying to solve the problem on our end. So you have to work at the speed of business to be able to do this effectively. Another example in the paint industry, this was actually this is a long time ago, this is from the Ford St. Thomas plant, so this is how long ago this was. What was happening was they were painting all these car hoods and they kept getting bubbles on these car hoods. They couldn't figure out where they were coming from. And so we got some of these parts and started looking at them. We would cross-section through the bubbles in the paint, and you can see, I have a laser here, no I don't. You can see the bubble here, and then you can see this crack underneath. And if you do some analysis, you can see, well, we've got our paint, the bubble, and we've got the zinc galvanized coating there, and then this flap in the steel. And what was happening was when they roll out these steel hood parts, roll out the raw material, small flaps would pop up from the seal surface, and then it would get squished down again when the roller would go across it, and all the mill oils and things would get stuck in there. And so then when you put the paint on, bake the paint, all that stuff that's trapped in there volatilizes, bubbles up into the paint. And so we worked on this over 6-8 months, collecting very similar results. And then the car company was then able to charge back to their supplier $500,000 worth of rework. And so it's just an ammunition, getting evidence. Another area we do a lot of work in is in mineral resources. So a good example is looking at the gold recovery process. So you take gold ore, you grind it up, you extract the gold in a series of leach tanks. You absorb the gold, and then that gets absorbed into an activated carbon, and you strip the gold from the carbon, and then you smelt the gold. A company was seeing that they were reporting somewhere around a 25% loss of gold. So obviously that's not good. Something's changed in the process, or something's changed in the ore that they're working with. And so we did a bunch of analysis looking at the gold itself. And you'll see the gold over here. Sometimes you get free chunks of gold, and then you'll have gold that's attached to ore, and then you'll have gold that's attached and somewhat locked within the other materials of the ore. And then you'll see some of the gold that's completely locked. And so you can make recommendations. Do you add a further grinding step, or do you add a roasting step, or things like that? And so something like this, a project like this would cost the client, say, somewhere between $50,000 to $100,000, but the return on investment can be enormous. So because we were able to figure out what was going on, they were able to put in process steps that then added $20 million a year in recovery. So small investment or large investment, but huge returns for something like this. Another example, we were involved in doing ASTM development of an improved salt spray test. And so they actually took these panels of zinc-coated aluminum, they put them on trucks, the side of cars, and they sent them out in the wild in various areas, so Montreal, St. John's, Cleveland, Detroit. And then we were involved in the analysis afterwards. And the thing here is that it was a huge project that involved many participants, many consultants, and we worked in this kind of mode with other groups doing various large problems as well that we need part of these sorts of things. So this idea that Mike came up with has translated to a facility with an international reputation that has run successfully now for 41 years and has employed multiple people, including some people in this room who come through either as grad students or have worked there. So thank you, Mike.
Well, thanks, Mark, very much for that talk, and give it a little context for Surface Science Western. I just made a little bit of a note because he talked about the St. Thomas Ford plant, and I drove past it yesterday, and now it's an Amazon warehouse. So things change. Our next speaker is apparently the easy side.
Can I make a comment? I don't want to suck up to Mike all day, but we started the exact same thing in Australia 10 years later based on Surface Science Western, where we ran things all day and all night. The government would give us money, and that was the least of our problems because we could get the money, never ask for it back. But then we had to run a business, and I was astonished to see 16 people. We had at maximum 6 people. And I just think that when I look at the history, I didn't realise the history before. I thought it was all Stuart McIntyre.
So Stuart he did most of this.
Yeah.
I got it started.
But I called him up because when we started, I just didn't realise, what a great deal that was. This was something that's national now in Australia, based on Surface Science Western.
Available to consult for the right fee.
You got to buy a copy of his book, though.